The last thing to set is the ability for the particles to bounce off a surface, and we don't actually have a surface, so we'll build one. I'm going to build a polygon mesh cube as my surface, and I'm going to flatten that sucker down a little bit, and I'm going to scale out the surface so it can encompass any bullets that might fall onto this plane. Now, this is going to be my obstacle. We'll just call this ground. And it's a non-deformed object. It's a static object. So I'll need to keep that in mind when I bounce off the surface. So I'll actually pull in the bounce off surface. I'll use the friction variation, the one that's actually been loaded up onto the community website, the XSI community website. It just has an extra control that prevents the particles from sliding indefinitely. And I'll connect the execute port of the bounce off surface into the ice tree, and I'll have to provide the ground as a surface. Okay, so when the particles are ejected, they're probably going to bounce very high, because if I double click on the bounce off surface with friction compound, the bounce factor is set to a very high level. Every time the particles bounce, they will continue to bounce to the same height. They won't lose any energy. Well, bullets do have some mass to them, so we'll take the bounce factor down to about, say, 25%. So that when particles bounce, there's a little bit of bounce, and that's about it. Now, we run into one other problem, which is that the particles don't actually stop. Even though they've got some additional friction, and I can raise the friction value as high as I want, the particles still continue to spin. So what we want to do is, once they've collided with the ground, we want to execute a change in the particle's orientation. So that's the last branch we need to set up. We need to make sure that they align with the ground and lie flat and stop rotating. So we're almost there. We'll add a little more functionality to our graph and move on towards the shading after that.